Welcome to Module 2. In this module we'll be discussing basic geometry, and in order to do so there's some terms that I feel like we need to discuss. So in your notes I have a list of terms that we're going to be going through. The good news is for you that most of these terms you're just not going to be tested on. I'm not going to ask you, okay, what's the definition of this, what's the definition of that. I am more interested in, can you utilize these terms in more real-world applications? The definition is good to know and it's useful in helping us, but when we go to apply it, that's where I'm more interested in. So let's start with some easy terms. Let's start with plane, not as an airplane, but plane, P-L-A-N-E. The definition states it's an infinite 2D space. Alright, best way I know how to describe 2D space is like this whiteboard right here. It's flat. It has no depth to it whatsoever. I just have length and a width. Now, a plane is flat. It only has length and width, but it goes on forever. It just never stops. It just continues to go. And I know that's a hard concept to wrap our brains around, so I'm not going to talk about it anymore. All right. Now, the next one, point. It is a position on a plane. So my whiteboard is going to be my plane. So a point is simply a position on a plane. I have a dot. It's on my plane. This is a point. Now, we can also name this point. Because I like it, I'm going to name it L. Hey, L, how you doing? All right, so that's my point. His name is L. Congratulations, you just met L. All right, but since a plane goes on infinitely, a point, well, there's only one spot, but there's a lot of different points. So we have this guy. Well, I'm going to call him J. Hey, Jay, how you doing? All right, so we got 2 points here. Okay, and we can have an infinite amount of points, but I don't feel like naming them all day. Now, a line. It says it is a straight path that passes through 2 or more points and continues infinitely. It doesn't end. So here are my 2 points. I'm going to make a line. Might be a little crooked, but it's a line that goes through them. Okay? This line goes through these 2 points, but it goes on infinitely. It goes on infinitely in this direction, and it goes on infinitely in this direction. All right? Ray is the part of a line that has a start and no end. All right? Well, there we go. I just took my line and kind of stopped it a little bit. So it starts at J, it goes through L, and it just keeps going through the roof. That's what a ray is. It has a start and it has no end. Line segment. It is the part of a line that has a start and an end. Well, here's my 2 points. It starts at J, it ends at L. It doesn't go in either direction, it just stops there. Or we could reverse it and say it starts at L, ends at J. It doesn't really matter, it just depends on what direction you want to go. Alright, now these are some basic terms that lead us to something that's really more important that I'm interested in, and it's angles. So, angle. 2 rays connected by a common point. The distance between them is measured in degrees or radians. So, we have 2 rays that are connected by a common point. It would look something like this. And we're going to name these points. And for the sake of time, we're just going to go A, B, C. So I have 2 rays. I have ray BA going all that direction. I have ray BC going all this direction. And together, they have a common point, which is B. Which brings me to my next point. Vertex. It is the common point on which an angle or angles, notice I can make more angles, are formed. So these 2 rays are connected here, and so this guy is what we call the vertex. Now, we have an angle, but the question is, what do we call it? Well, we can give it a couple of different names, but it all depends on what points we're using. Okay? Well, this thing has points A, B, C. So we could call it angle A, B, C. Well, I don't like that one, so let's give it a different name. I could call it angle C, B, A. And then finally, I could call this thing angle B. All three of these names are correct. I could call it angle ABC, angle CBA, and angle B. Now, what do you notice that they have in common? B. If you are going to name an angle, you can name it just by the vertex, which is B, or you can name it by the 3 points, but make sure that the vertex is in the middle. Why? Because the vertex, if you look at it, is in between these two. It's in the middle. That's why it's so important to know what the vertex is. So let's change this ever so slightly. I'm going to erase that. So my question to you is, how many angles do you see? Well, you might see 2, you might see 1, but let's look at it. All right, so first one. We know that this one, and this one are at 1. So we can say angle ABC from here to here. That's an angle. All right, what other angles do we see? Well, I see one here. I'll use long dashes this time. That's angle ABD. So that's our first angle was ABC. Our second angle is angle ABD. Do we have any more? Yes. It's the out angle right here. And I'm just going to draw a solid line just kind of showing it. Okay. Angle DBC. Now, there were 3 angles in this picture that I drew. So I'm going to erase this so it's not too terribly confusing and just go back to the original angles. So we have 3 angles in this thing. What do they all have in common? The vertex. So if you told me that there were 3 angles and you just said that they all are angle B, you would be incorrect. Why? Well, angle B could be any of these 3. You need to be specific. Think about it this way. My name is Lewis. My last name is Lewis. So you wouldn't just say, hey, Lewis, when you have a room full of Lewises in a classroom. You're going to be more specific and say, call me by my first name. Hey, Jonathan Lewis. That way, I know who you're talking to. Same principle. The vertex is kind of like the angle's last name. You don't just always call it by, hey, B. You need to call it by its full name sometimes. Now, earlier I told you that when we look at angles, we also look at the distance between the 2 sides of that angle. And we usually do that through measurements of like through protractors, computers, etc. blah, 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 blah. It doesn't really matter. And we find out that there's 2 ways that we can do it. One is we can get a measurement in degrees, which is probably what you're used to. And the other one is what we call radians. We'll talk more about radians later on in the semester, but not right now. So let's keep things simple. So for the sake of argument, we could say that this was 35 degrees. Okay, that's pretty straightforward. Now, there's some special types of triangles that are based upon how many degrees are in that triangle. So I'm going to show those to you on the board right now, so you should see them. So the first one is a right angle. A right angle is essentially where the 2 sides are 90 degrees apart. Okay? This is a very important angle. It's almost where just about everything that we will be doing is based upon how this angle works. The next one is what we call a straight angle. Let's just call it a line. A straight angle and a line are the same thing. And a straight angle has 180 degrees. Okay? The next one is an acute angle. It's an angle that has less than 90 degrees. Think back to probably when you were in elementary. Your teacher said, just to say, oh, you know how you can tell it's an acute angle because it's so tiny and so cute. If If that helps you remember it, fine, okay? Acute angle is less than 90 degrees. Now, an obtuse angle is more than 90 degrees, so it's like, your teacher probably did that. Well, my teacher did anyway. I don't know what they were doing. Extracurricular activities at home, I guess, is probably why they could do some weird stuff. But anyway, obtuse angle is bigger than 90 degrees. Maybe you'll remember that. I don't know. All right, so obtuse angle bigger than 90 degrees. I'm going to pause the video right here. I forgot to mention when I was recording this lesson, not only is obtuse angle bigger than 90 degrees, but it's also less than 180 degrees. So it's bigger than a right angle, but smaller than a straight angle. Okay, back to the video. All right, the next two big things are perpendicular. All right, so in this picture you see two lines are crossing and they make a 90-degree intersection. Makes sense? Just basically think of it like at an intersection with four stop signs. Excuse me, stutter. Now, the last one would be parallel. And parallel is basically when two lines never cross. Next in your notes, we have some special angles that I really want you to understand. And these angles are more like rules and how things work together. So up on your board, we're going to talk about first what's called supplementary angles. Basically, a supplementary angle is when I take two angles together and when they add up to 180 degrees. So in this one we've got up on the board, I have two angles that we see. I have angle ABD, so that would be this guy right here, all right? And then I have angle DBC, which would be this guy right here. Now, for the sake of argument, let's just say that ABD is worth 135 degrees. Well, we know that these two are supplementary angles. So if angle ABD is 135 degrees, how do we find what BDC is? Well, we simply subtract. What's 180 minus 135? And we get 180 minus 135. We know how to do this. Will become a 10. That's a 5. That's a 4. Those go away. So we find out that this is 45 degrees. So angle ABD is 135 and its supplement is angle DBC, which is 45 degrees. Our next one that we're going to talk about is complementary angles. Complementary angles are basically when two angles add up to 90 degrees, where supplementary is 180, complementary is 90 degrees. So here we have two angles, okay? We know that when we add these angles together, which happen to be ABD and DBC, when they're combined, we get a 90-degree angle, which is shown right here. So let's say for the sake of argument that we know that angle ABD happens to be, let's say 36 degrees. My question to you is, what is angle DBC? All right, so angle ABD is equal to 36. We're trying to find DBC. How do we go about doing that? Since we know that these are complementary, we simply subtract the 36 from the 90. So 90 minus 36. This goes to 8, this becomes a 10, this is a 4, this right here becomes a 5, so 54 degrees. 36 plus 54 does equal 90. So, complementary angles are when two angles add up to 90 degrees. Our next two angles are what we call adjacent angles and vertical angles. Now, adjacent angles are simply this. They're when two angles share a common side. So we see two angles, BAC and CAD. However, they could have a common side of AC. All right, that's all an adjacent angle is. They share a common side. Now, vertical angles, I'm going to give you the definition here, occurs when two lines cross to form equal angles on opposite sides of the point of the intersection, which is the common vertex. Long story short, you have two lines, they've crossed one another. Where they cross, this is our vertex. Okay? All right? This is why we call them vertical angles, not because they're vertical of one another, but because they share the same vertex. Whereas an adjacent, they share the same side and the vertex actually. This one, they just share the same vertex. On top of that, here's the cool part. If you know something to be a vertical angle like this, if you know that from here to here is 130 degrees, you also know that it's just directly below it, or whatever it's pointing to, is also 130 degrees. Basically, think of it like this. If it's 130 degrees here, its mirror image is also 130 degrees. Well, let's go ahead and use our rules dealing with supplementary. We know this is a line, so if from here to here is 130, what do we know this to be? We know it to be 50 degrees. Why? Because 180 minus 130 is 50. Well, if this is 50 degrees, we can use the rules of vertical angles and say, hey, its mirror is also 50 degrees. This one key concept with vertical angles, if you can grasp this, it is going to save your life in this class. The next big concept is called transversal. The definition states a line that crosses two or more parallel lines. So in my picture here, I have two parallel lines. I have this one and this one. And a third line is cutting through both of them. This is what we call a transversal. It's basically transversing the two parallel lines. Think of it from that standpoint. This leads us to our next three types of definitions. One's called corresponding angles, alternate interior angles, and alternate exterior angles. Now, there's no good way of trying to have a written way of defining this. It's actually easier just for you to see what they are and maybe define it in your own way. So, what's happened is when we've taken this parallel line and we've cut it by transversal, we've made some angles, and we're going to go ahead and label them. We're going to say angle 1, 2, 3, 4. So 1, 2, 3, 4, 5, 6, 7, and 8. Now, corresponding angles basically are angles that are the same. Okay? So if you look at angle 1, see its shape? That shape of angle 1 is identical to the same shape of angle 5. So some corresponding angles would be angle 1 is equal to angle 5. Now, let's look at the next one. Angle 2, its particular shape, is equal to the same thing as angle 6. It's the same type of shape. The only difference is it's kind of been moved. So we can say angle 2 is equal to angle 6. By this pattern, you should be able to figure it out by now. 3 is equal to angle 7. And then lastly, we can say angle 4 is equal to angle 8. Basically, that's your definition for corresponding angles. Angle 1 is angle 5, 2 is 6, 3 is 7, 4 is 8. Alright? Now, alternate interior angles. What we have to do is look at the inside between the two parallels. Alright, so we have 3. Well, 3 does not look like 5. However, if you were to put a mirror up here, 3 does look like 6 when flipped upside down. So the alternate interior angles would be 3 is equal to angle 6. And the same thing applies. 4 looks like 5 if it's flipped upside down. Alright? Alternate exterior angles. So now, where before we were looking at the inside, now we're going to look at the outside. So let's look at 1. Well, 1, the alternate angle, well, it would be 8. So 1 looks like angle 8 if we flipped it upside down. Same principle. 2 looks like 7. These are your basic definitions. This is not, I could try to word this out for you better, but I feel like it's more important for you to see it. So, how does this really help us? So, why are these definitions so important? Well, let's say I give you my two parallel lines and a transversal, and I'm going to say that this angle right here, we're going to call it, we'll make it nice and easy. We're going to say 130 degrees. All right? Your job now is to find all of the remaining angles. You got to find everything else. Hey, this is where it's a walk in the park. All right, so first off, let's concentrate just on this guy right here. We know that this is a line, and basically this angle and this angle are supplementary. So we can say 150 minus 130, and we find out that this missing angle is 50 degrees. Now, let's use some of our other rules. Well, we can start using all the corresponding stuff, but let's just concentrate just on these two. Well, what does this remind you of, just this top portion? It should remind you of vertical angles, because this is a line being crossed by another line. Well, if this is 130, hey, guess what? That's 130. And if this is 130, guess what this is? Well, it's going to be 50. Okay? You just found out your vertical angles from here to here. Now, how are we going to find this part? Corresponding angles. Whatever was here, hey, I'm just going to transfer it down here. 50, 130, 130, 50. You've just done it. Just that simple. Lastly, I just want to finish up with these final two definitions, are really probably rules. A triangle has 180 degrees, just like a straight line. It's always going to have 180 degrees, no matter what type of shape of triangle it is, always 180. Okay, so like in this little problem, if we know that rule, we can actually find the missing angle. We know that this angle right here has a 30-degree angle to it, and it also has a 23-degree angle. And we want to find E. So really all we're going to do is say 30 plus 23 gives us 53. And then we say 180 minus 53, and we can use a handy-dandy calculator, or we can just do it on paper. Really doesn't matter. And we get 127 degrees. I just did that on paper real fast. So angle E is 127 degrees. Let's find out if I'm right. Hopefully I am, and I'm not too much of an idiot. I'm all right. Okay. So the last definition is with circles. A circle has 360 degrees. It will always have 360 degrees. With that said, we have a pipe flange here, and we're trying to drill 8 bolt holes that are equally spaced from one another, and our job is to find out how many degrees apart they are. Well, if we know that there's 360 degrees in a circle and we need 8 holes, we simply can say 360 divided by 8. And when we do use a handy-dandy calculator, we should get 45. I did that in my head. Let's see if I'm right. Hey, I'm right. Okay, so that's pretty much it. Remember, a triangle always has 180 and a circle has 360. These are two main rules of thumb that you need to remember. All right, I'll see you in the next video.